and welcome to my video on finding functional groups in organic compounds. What I want to express to you guys is that oftentimes on your diploma, you're going to be given an organic compound that looks foreign to you. Now, I don't want you to panic. What you need to be able to do is find the functional groups in these structures. So don't panic, it's not that difficult. We can get through it together. What you're going to need for this lesson is you're going to need your workbook, and you should be open to page 40. You're also going to need your data booklet, and you should be open to page number 9. We're going to start by looking at the general formulas and names of some of the organic compounds that we're going to take a look at, starting with the bonds. So we all know there's 3 types of bonds. There's alkane, alkene, and alkyne. Depending on whether it's a single bond, a double bond, or a triple bond, that's where we get our classification from. So let's take a look at alkanes. Alkanes end with A-N-E. And that just signals that they have a single bond between the carbons. A-N-E. So what we're going to see in our example for ethane is that there is only a single bond between our 2 carbons. Alkene is next. It ends in E-N-E. And what we're going to see in our example is ethene. Between our carbons, we have a double bond. Last, we have alkynes that ends in Y-N-E. And what we're going to see in our example is between our carbons, a triple bond. When we take a look at the names of our examples, we're going to see that depending on the type of bond, that is the actual name we're going to come up with. So for example, when we're talking about a single bond, we're talking about an alkane. Our name then for our example is going to be eth because there's 2 carbons, ane because there's a single bond between them. Okay. Alkene is the same. Again, we have eth because there's 2 carbons and ene because there's a double bond between them. Same with alkyne. We have 2 carbons, that's where we get our eth from, and we have a triple bond, so that's where we get our ine from, Y-N-E at the end. Now the first functional group we're going to take a look at is what we call an alcohol. In our general formula, they're giving us R single bonded to our oxygen, single bonded to our hydrogen. All that R means is we can have a huge chain of carbons. Doesn't matter how many carbons there. That is what is represented by R. But when it comes to our alcohol, the most important part to remember is that OH. Okay? Our alcohol always has an oxygen single bonded to a hydrogen at the end or on the outside of our actual structure. So let's take a look at the example they're giving us. They're giving us ethanol. What we're going to see now is that we have 2 carbons. That is how we get the eth part of our actual name. Now, the last part, the ol, comes from our alcohol. And this is what we see with our functional group. Our functional group here is right here. It's that oxygen attached to our hydrogen with a single bond. That's how we get that ol at the end for our alcohol. Our next functional group is our carboxylic acid. Now, I gotta warn you, this functional group looks really intimidating because now we have a carbon that's double bonded to an oxygen on one side, single bonded to another oxygen on the other side, and that oxygen is also bonded to a hydrogen. So it looks really intimidating, but do not panic. Carboxylic acids are easy to spot. So again, Just to highlight our functional group, it's our carbon, double bonded to our oxygen, single bonded to another oxygen that is single bonded to a hydrogen. In our example, we have ethanoic acid. Again, we get the ethane because we have two carbons, and we get the ending oic acid because of our carboxylic acid functional group, which is at the end. We have that carbon double bonded to an oxygen, single bonded to another oxygen that's attached to our hydrogen. That is our carboxylic acid. And we always end our names with oic acid when we're talking about our carboxylic acid. Our next functional group is something that we call an ester. Esters are unique because they're different than any other functional group we have. We actually see esters in the middle of our structures. So what you're going to see in the general formula column is an R on one side and an R on another side, meaning we can have chains of carbons on either side. But what's important is that you notice what's in the middle. That is what we call our ester. Now we're talking about a carbon double bonded to an oxygen and single bonded to another oxygen in the middle of our structure. Now, an ester is actually an alcohol and a carboxylic joined together. Remember, our alcohol has a functional group of OH. All we're doing in an ester is we are adding a carboxylic acid as well. So now we're adding that carbon with that double bonded oxygen, a single bonded oxygen, and that hydrogen with our actual alcohol. Now when this happens, a few things join together. We're going to find that this OH from our alcohol is going to join with this hydrogen from our carboxylic acid. And when that happens, it gives us HOH, which is actually water. So we can write it as H2O. Now what we're left with is our actual ester. We are left with that carbon double attached to our oxygen with a single bond to another oxygen. This is our ester. Now, when we're taking a look at an actual structure, the first thing you're going to notice when you're looking for an ester is that our functional group is our carbon double bonded to our oxygen and attached singly to another oxygen. And it is always going to be in the middle of our structure. When we're taking a look at the name, we're going to notice that there's two words involved. The first word is our actual alcohol. So this has to do with our alcohol. The second name we're going to see has to do with our ester. And by ester, I mean carboxylic acid. Sorry about that. Now, let's take a look at our structure. The first word is referring to our alcohol, methyl. So our alcohol actually refers to the single carbon here. This is our alcohol. Now, the second part of our word is ethanate. Okay? Ethane, again, refers to two carbons. So you see these two carbons here? Usually, when we're talking about our carboxylic acid, we're talking about the carbons attached to our double bonded oxygen. So this is our carboxylic acid here. Now we're joining our acid and our alcohol together with that ester in the middle, our functional group in the middle. And that is how we get our final structure. Now our last functional group is what we call a halogenated hydrocarbon. It sounds intimidating, but is actually one of the easiest of our functional groups. All we're going to see is that we're going to have a carbon chain, represented again in our general formula by R, and it's going to be attached to something else. So something like fluorine, chlorine, bromine, iodine, anything else. All we're doing in our carbon chain is we're replacing hydrogens with another halogen. So in our example, we have chloroethane. What we're going to see is instead of our hydrogen being present, we're replacing that hydrogen with chlorine. And that is how we get our halogenated hydrocarbon. So just to give you an idea, it's going to be a halogen, so it can be replaced by fluoro, chloro, bromine, or iodine. Anything else besides a hydrogen there. Now there is one last structure that is not on page 9 of your data booklet, and it is a benzene ring. Benzene actually is 6 carbons with 6 hydrogens. And normally, when it is drawn out, it looks like this type of honeycomb shape. Okay? What you're going to see is at each point, it represents a carbon. Now, between some of these carbons, there's going to be a double bond. And between the other carbons, there's only going to be a single bond. Things with benzene are actually really difficult to break down. Most often, they do not break down easily. Now let's take a look at your actual workbook. We're going to turn to page 40 now if you haven't already, and we're going to do 2 examples. I'm just going to highlight the examples we're going to do. We're going to do the 2 last ones. So this example and this example. We'll start with the 2-4D example. Now the easiest thing to pick out, of course, is that kind of hexagon or honeycomb shaped structure. This is, of course, our benzene ring. Now remember, at the points, we have carbons. If it helps, feel free to draw them in. So at each point, there's actually a carbon here. Okay. What you're going to notice, too, is that there's other functional groups present here. Remember, our carbons are usually attached to a hydrogen, but in this case, we do not see a hydrogen, we see chlorine. Do you guys remember what that is when we replace our hydrogen with another halogen like chlorine? That is when we get our halogenated hydrocarbon. All right, there's one more functional group here. It is at the end of our structure. It is this carbon attached to 2 oxygens and our hydrogen. Do you guys remember what that is? Carbon double bonded to an oxygen on one side, single bonded to another oxygen on the other side with a hydrogen. This is what we call a carboxylic acid. And that is it for that example. Let's move on to the last one. Right away, you're going to see that ring structure. Remember, that ring structure is probably the easiest to pick out, so I always pick it out first. This is what we call our benzene ring. Now remember, our benzene ring is made up of 6 carbons at each point. If it helps, go ahead and draw them in. Now what you're also going to notice is a few other functional groups present. We have one that is actually in the middle of our structure, right here. It is a carbon, which I'm going to add in here, double bonded to an oxygen, single bonded to another oxygen in the middle of our structure. Do you guys remember what functional group comes in the middle of our structure? This is actually our ester. Now we know in this example we're joining both an acid and an alcohol. All right, there's one more structure here, and it's going to be easy because I just gave it away. Our last structure has to do with this OH. Do you guys remember what an OH is? It is our alcohol. And that is it for our last example. Go ahead and try the other examples on page 40 and see how you do. Remember, it's like riding a bike. It takes a little bit to pick these things out, but once you get used to it, you can get really fast and really good at it. Good luck.